Yeah guys, welcome back to session 13 of Java Full Stack Made Easy. So previous session we were discussing about the collections, right? And in a collection we have discussed only about a list implementation, and within the list implementation we have discussed only about the vector. So this was my last example where I was discussing a vector wherein I created an instance of vector and I also showed you how do we create a generic vector and a raw type of vector, and also we have seen what would be the difference between creating a generic one and raw type. And from Java 1.5 we should not be creating a raw type vector because raw type vector basically is a heterogeneous collection and we have to always make use of a homogeneous collection. In case if we want a heterogeneous collection, at that time we can create a vector or any collection class with object class, so that it will be better for us to manage the collections. Fine. So an example of auto boxing I have already shown you, wherein I added this primitive type and that got converted into a class type, and we have tested that by using a get method. And after doing a get method here, roll number dot get 0, that means 0th item. Now I have all the integer class variables here. That's because it is automatically converted, and int value is converted into integer. So that's what we can say, it is auto boxing. Now the next thing what I would like to add in here is that, see, the values I'm directly adding 20, 30, 40 and all, right? So now what I'm gonna do is I will try to make use of a remove method here. Fine. So let's see what happens if I use a remove method, and it is a integer type of collection that I'm creating. So let's go ahead and try and see that remove method, and with that one more important point we will learn. So here I will try to use a roll numbers dot remove, and I want to remove 30 from there. Okay, so let's save it and try and run this and see whether 30 will be removed or not. So if it is removed, I want to print the vector after that. So let's check whether it will be removed or not. So let's run it and see the result. It says the Java lang array index out of bounds exception at the range 30. So this 30 is not considered as a value, it is considered as a index position. So you see here, control space, if I give, this remove is for index, right? So one takes an index, another one takes object, that means the value. So it should remove it based on the value. With the integer values, that's not the case. So let's see how things work now. How should I make it consider this integer value 30 as a value? Okay, so that is because, see, I want to now remove 30 from here. How will I remove 30? I wanted to consider that 30 as an value, integer, not the index position. Index positions are primitive types, right? Whereas the values present into this is an object. So what I have to do in that case is I can say integer I equals to 30. Now since it is I, an integer, not a int, not a primitive, so now if I give I, now the I will be considered not as a index position, it will be considered as a value. So I can now remove this 30 and remaining values will be printed to me after removing that. Okay, so let's now run this and see that. So in the previous example, when I was just writing it as 30, so it was giving me an error. Now it is not giving me an error because in the previous example that 30 was considered as an index position, whereas now it is considered as a value. So I'll write that as well. Remove 30 directly. So this line would give you an error. Error 30 is considered as index position. So since we don't have that index here, right? So that's why it will give you an error. So I'll copy this and put this into the repository. So we will call this as, this is session 23, so we will call it as day 23 as we are following that approach from day 1 itself. So this is going to be our day 23 / demo 1. Let's call it as remove by index or value. So remove method is overloaded in two ways. One is either by index position you can remove it, or by value. With integer this comes up as a problem. So if it is any other type of vector, that means if it is of type string and all, so directly you can pass the value and it will remove the element, or you can give a index position, it will remove the element. Only confusion will come up when we have this thing here. Fine. So with the vector we have learned a lot of set of rules and everything. Now let's convert the same vector into a array list and see things how it works. So I'll show you again the collection hierarchy. You can see that this collection here, we are talking about the list implementation, the list interface, and these are the classes that comes from, that implements the list interface. So we are talking about vector now. Let's compare that vector with an array list. Fine. So let's see how things work when I take a array list. So I'll go here and I'll change the vector to an array list. Let's change this to an array list. Array list, roll numbers, new array list. Fine. So now I'm creating an array list. Rest all things will remain as it is. So whatever I created before would remain the same. So be it the remove method or whatever, I'll keep it same. Add method, the remove method and everything. Now I'll save it and run it, and you will see that the result is same. Correct? Result is exactly the same. So there is no difference in the result. Array list also contains add method, also contains the method, this one, the remove method, and add and overloaded add method is also there. So everything is same itself when it comes to an array list. Now what is the difference between an array list and vector, right? So let's talk about the difference, because that is one of the interview question again. What is the difference between a array list and a vector? So we will talk about the difference. There's one major difference between array list and vector, so I will write that here. You should remember that. And now vector is not in use, so I'll just remove that vector. Vector versus array list is what we are checking, right? So vector, thread safe, that means it will be slow. Whichever class is thread safe, it has to be slow. And array list, again both are list implementation only. This is not thread safe. If you remember, we talked about a string buffer and a string builder. String buffer was thread safe, string builder was not. So because of which a string builder was fast and string buffer was slow. Similarly here also vector is thread safe, so which makes it slow, and it is used for what? Multi-threaded applications. Let's call it as multi-threaded application. And this array list is fast and it will be used for a single threaded applications. This is not thread safe but fast, and it will be used in single threaded application. Fine. So this is the major difference between a vector and a array list. Rest all methods and everything are same itself. That's because both are the implementation of list interface. The methods that are available into list interface will be there in array list as well as will be there into vector, right? Okay. So let me copy this and put it into the repository, and let's call it as demo to an array list. Demo to array list. All right. So in both the examples that I have used up till now, I am iterating over the collection by using an enhanced, just by printing it. I did not use an enhanced for loop, neither I used a iterator. So we'll discuss about that. But before that, what you can do is whenever it comes to these applications and everything that we are using, so at that time what you can do is an array list versus vector. You just type that into your Google and it will tell you what exactly the difference between array list and vector is. So I think your tutorials point should give you better differences. Let's see. Yeah, so here a detailed difference between what is array list and what is vector should be given to you. Main one is thread safety. Fine. So you can see that array list is not synchronized. The vector is coordinated. If the array's capacity is exceeded, array list increases the size of array by 50%, whereas for vector it increments by 100%, doubles. So what do we mean by these things? So let me just go to the code and make you understand the capacity. See, what happens is whenever we are creating any array list or vector, while creating the array list I can also give the size here like 5, or maybe I can give 10 here. So if I give it 10, at one given point of time 10 memory blocks will be reserved for this array list. Fine. And after inserting or after utilizing that 10 memory block, array list will increment it by 50%. So that means it will reserve 5 more memory blocks. Whereas if it was a vector, at that time it will reserve 10 more memory blocks. What would be the advantage of initializing it at the beginning only? The advantage is that, see, every time if you are creating a memory and then inserting an element, it will be slow. If you create 10 memories first and then start inserting an element, it will be a bit fast comparatively. You take an example of something like this. If 10 guests are coming to your home, you will not prepare food one after another, right? You prepare a food, one plate for one person, then again one plate, then again one plate. You will not prepare it that way. You will prepare for 10 people, right? And then you feed them. So that's what reserving 10 memory blocks. So obviously this process, preparing the food for 10 people at one time, saves time rather than preparing it for one single person, right? So that's the same thing happens with the memory also. Okay, array list is not synchronized, it is quick, so that means array list is fast, whereas vector is synchronized and obviously it will be slow. So array list has to be used when you are using single threaded application, and vector should be used in multi-threaded applications because that is safe. And one important point about the vector and the array list is that a vector is from Java 1.1 itself. Array list was introduced into Java 1.2 later. You can see that difference here. ArrayList is not a legacy class, it is introduced into Java 1.2, whereas vector is a legacy class. That means it is there right from Java 1.1. Okay, so the iterator interface is used by ArrayList to iterate across the entries. A vector can navigate the element using either the iterator interface or the enumerations. So they say that enumeration is basically applied on the legacy classes, not on the modern classes that were introduced into Java later. Okay, so that is one more difference. But the main difference between a vector and a array list is that vector is thread safe, array list is not. Okay, so you can take this link and you can read out more about this differences as well. So you can go to tutorials point and from there you can learn the things. So it'll give you a detailed description about it, but I spoke about the main difference. If I start talking about every single difference there, obviously the video is going to be too lengthy and it will require some 10 sessions for us to only study about each and every class available into a collection. Fine, so I think I've already shared this code with you in the repository. Let me check it once. Yeah, array list is already shared. So let's go ahead and talk about the other things available into a array list. Like I was talking about iterating over a collection. So while iterating over a collection, we have options. We can either use an enhanced for loop, or we can use an iterator as well, or we can use a enumeration. So let me just clean up everything, that remove and everything from here. So I want to iterate over this collection. First I'll show you how do you iterate over a collection using a iterator, because we already know how do we use a enhanced for loop, right? So let's go ahead and see how do we use an iterator. So this name of this collection is roll numbers. So let's take that, roll numbers dot iterator. This particular function is available with us, and you can see that it returns us an instance of iterator, that is the interface. The return type of this method is iterator. So let's use that function, and the return type is iterator, so we have to store it into the type of iterator. So here it is available in Java util iterator. And what is the type of this array list? Integer. So iterator type will be integer itself. So it depends on the type of list, or maybe whatever you are using, maybe a list or a set. Depending upon that type itself, you will get the iterator type. So I got this iterator of type integer, and now I will call it as itr is equal to. Fine. So once we do that, then what I can do is I can make use of a while loop to iterate over this, because this iterator has a function called as hasNext, and hasNext will return me either true or false. It will return me true if there is a next element available. It returns me false if the next element is not available. Okay, so let's go ahead and try and iterate over it and retrieve the elements from there. So I'll say while iterator dot hasNext iterator dot hasNext. So as long as there is a next element there, you give me the next element. That's what I want to say. Okay, so let's just say system.out.println itr.next. Save it, and we can iterate over the collection and retrieve each element. Okay, so in all the previous cases I was just printing the entire collection. Now I'm iterating over it. So an advantage of iterating over the collection would be what we can manipulate with it. That means we can maybe what we can do is we can add 10 to it, or maybe add 2 to it, or maybe what we can do is we can check whether the next element is odd or even. So these type of things can be done. If I just print it, there's no use of it, right? So while I'm iterating over the elements of a collection, I can perform any manipulation. Like maybe I would like to say itr.next plus 10. So each element will be given to me with 10 extra to it. So first element is 11, so that will be 21, then 30, 40, 50, 60 and 2010. So that way I am just adding 10 to the elements. Fine, elements are added. Similarly, if I want to check whether the next available element is odd or even I can do that just by checking whether the next element is next element modulus 2 equals to 0, and if it is even, print even. If it is odd, print odd. That way I can print it. But one more important point here is, suppose if I am doing it like that. So after doing that, I'll just comment this. I'll check if the next element, that is itr.next, if the next element is divisible by 2 and it returns the remainder as 0 to me, then system.out.println print me that this element is even, plus also give me that next element itr.next. So if I am doing something like this, else I want to tell that it is odd number, you see in this case what will happen, odd, and I'll not add this. So let's just add something like 11 is added here. So I'll add it on my own. Let's say I'm adding 11, 12, 13, 14. So this number is an odd number, even number, odd number, even number. So 2 odd numbers are there, 2 even numbers are there, and for even number it should show me what even number, for odd number it should show me what odd number. So let's save it and run it and see whether it returns us that or not. See, odd number 12 and odd number 14 is what it is showing us. Why is that? That is because, see, in ITR we are using this next element here. So next element is retrieved. What is the next available element? At the beginning, very beginning, we have added a 11 here, right? So it will go to false, right? And in here what happens is it will print odd, and then after that itr.next it is printing me the next element again, 12. So this type of thing should not be done here. So you should not be using itr.next, itr.next, itr.next. 3 times, 2 times I'm using itr.next, every time it will be pointing to the next available element. So what should be done in such cases is that, so I'll put this into comment because this is the problem. So these type of things should not be done. If your requirement is like that, then what you need to do is you simply create int next is equal to itr dot next. So you store that element into a variable, then keep comparing that element like this. If next, and then keep using the next instead of this itr dot next and all that, because next is a variable, so that will remain as it is, and itr will be called, itr dot next will only be called once here in the next loop. So now it will be proper. Fine. So I hope you have understood why should not be we should be using this itr dot next all the time. So let me copy this and put this as well into the repository. This is demo 3 iterator. So here I am iterating the collection using the iterator. Fine. So using an iterator and using either an enhanced for loop or maybe an enumeration has a difference in it. What is that? An iterator is not a read-only thing. Iterator allows you to modify the collection while you are working with the collection. Now what do I mean by that? So let us understand that, and then we will compare that iterator with an enumeration and see that. Okay, first let's see the example, how can we modify the elements available into the iterator. So as for now, I have created some elements into the iterator, so let's go to this tab instead, and that will be fine. So what I'll do is I'll just clean up everything, this comments and everything that I have written here. So let's remove the comments. Now I will have an iterator, and then what I will do is I will just try to say let's not write this odd and even, let's just print that next element. All next elements will be printed to me, and after that what I will check is if itr, that is if next, that itr dot next, if it equals to 10, in that case what I want to do is I want to do a itr dot remove. So there is a remove method available into iterator basically. So I can remove the elements based on any condition. I can make use of this remove. That tells me that it is editable. Fine, it is not read only, it is editable. So outside this while loop, what I'm gonna do is I will check what is there in my collection. So I can iterate over the collection and tell you what is there, or else I'm just gonna print it as roll number. Okay, let's print it and see what is there in this. So I save it, and yeah, I don't have 10 at all, so I'll go for 11, save it and run. Now you see that 11 is removed from my collection. So my iterator is editable. It allows me to edit the collection. It allows me to remove an element from the collection. Fine. So while iterating over a collection using an iterator, at that time I have a method called as remove that allows me to remove the elements. Okay, let me copy this and put this into the repository, and now I will show you the difference between the iterator and enumeration. So this is demo 4 iterator remove. Fine. So these differences, obviously as the time progresses you should be learning this. Okay, so let's call it as iterator versus enumerator. Okay, enumeration basically, enumeration versus for loop or a enhanced for loop. So enumeration is read only, whereas iterator is editable. So which means that, and also enumeration can only be applied on legacy classes. Iterator can be applied on those classes which are added into Java later. So let's see the differences. If there is a table, it is well and good. Let's see if there is a table available. Yeah. So you can see that uh, Iterator, universal, applicable to all collection classes in Java collection framework. Enumeration, limited to legacy classes like vector and hash table, because these are the classes that were available in Java from right from 1.1. Operation supported, supports read and remove operation, whereas in enumeration only supports the read operation, it is read only. So methods that are available into an iterator are like has, next, next and remove, whereas here we have has more elements and next element. Similarly, now provides fail fast behavior during iteration, does not support the fail fast. And lastly, preferred for traversing, that means iterating modern collections like hash map, ArrayList, etc. And this is obsolete in modern applications, primarily used for legacy collections. So this is the difference between our iterator and enumeration. So whenever you want an editable collection, if you want to make use of a remove method, you have to always go for iterator rather than going for an enumeration. Fine. So let's go ahead and I will also show you an example how can we perform sorting for this collection. So let's see how do we perform sorting here. Let's go back, and this collection, the differences between each one of them, it should, as the time progresses, you will come to know those things, but you have to remember these things. Fine. So these are very basic things about the collections which we have to remember. These are all ready-made for us, but requires us to remember the things. So let's go ahead and see how can we perform sorting. The collection that I'm using here, the roll number and everything, this is ordered but not sorted. Ordering is different, sorting is different. So let me show you this, the concept of ordering, that is let's say 111, let's call it as 13, let's call this as 150, and let's add more, some 2 more, let's call this as 14, and let's call this as 1. So it is ordered. First of all, ordered in the sense, if I print it, it will maintain that order. Okay, it is going to maintain the order in which I have added the elements. So order is maintained. You can see 11, 111, 13, 150, 14 and 1. It is not sorted. When it comes to sorting, it can be sorted into an ascending order or descending order. Okay, ordering of collection is different, sorting of collection is different. Do remember this important point. Now let's see how do I sort this in an ascending order. So to sort any collection, a list, basically I have to use collections. Now you see there is something called as collections in Java util, which is a class. Okay, collections dot sort. Another interview question that might be asked to you is difference between collection versus collections. Collection is an interface. Okay, collection is interface, whereas collections is class. You can see that in the hierarchy also. This collection is interface. I am not using a interface collection, I am using collections. So that might be one of the interview question for collections in Java. The collection is an interface from which your set, queue and list is derived. That means not derived basically, because set, list and queue is not a interface. So collection is an interface which is implemented by set, implemented by list and the queue. Whereas collections class allows us to sort the collection. Now to sort the collection, what is required here? So if you see the sort, it asks you the list. So you provide the list, it will sort it automatically. What is the name of the list? Roll number. So I'm creating a list of collection roll numbers. So since it is an integer type of list, we can just simply sort it by using a sort method. So after sorting, let's see what is the result. So I'll say system.out.println. Before sorting, I'm printing these roll numbers, and I'll say after sort. So after sorting also, I want to print those roll numbers and see whether the sorting has happened properly or not. So after sorting, I'm printing the roll numbers. Let's save it, run this. So you can see that this is how it was before. It was ordered, it maintained the order in which the elements were added. Now after sorting, I have sorted it in ascending order. So by default it does that. Collections.sort function is used to sort the collections. So the default order of sorting is ascending order. You can also perform a reverse order sort. So you can sort it in reverse order as well. Now how do I sort it in reverse order? So let's say system.out.println descending sort. Okay, so for performing a descending sort, I'll take this collections.sort itself first, and I'll print this. Now you see when I have this sort, whenever I'm performing a sort, again this sort built-in function, you can see it here. It takes a list. Second overload for this sort is that give the list and give the comparator. What is that comparator? A comparator is an interface in Java that gives you the logic for sorting. Sorting logic is written in comparator. Okay, so we have to use this list. First of all, two arguments. One is the list has to be passed. Which list I want to order? It is the roll number that I want to order. So roll numbers, and in which order I want to sort it now? I want to sort it in descending order. So I have to write a comparator and then give the logic there. So because of this descending order sort, there is already a method available in collections that reverses the order. So I can use again a built-in collection dot reverse order. This method is readily available for me. So I can simply say reverse order and that will sort the collection in descending order. So let's save it and I'll show you how things work now after I perform a descending order sort. Let's save it and run this. Now you can see that very first output is for how the list looks like. This is the ordered, this is how it was ordered. Then after that I performed a ascending order sort. Then I performed a descending order sort by using a reverse order. Fine. I hope the things are clear to you, how we can perform sorting in collections and also reverse order sorting. So I'll put this as well into the repository. See, in Java, this collection interface is all about the data structure, but everything is ready-made for us, so it will be easy for us. We have to just know what collection we want, what is the behavior of that collection, and what all functionalities it provides us. So this must be a demo for sorting collection. So this is an integer collection that I have sorted. What if this collection is of type string? Whether that type of collection can be sorted or not. So yes, even a string type of collection can be sorted. So let's go ahead and create an array list of type string. This one, array list of type string. And see, you will always see the examples being given to you like this. A list and the list of type string. You will not see array list is equal to new. You'll see a list. That's because we know already we have seen what? We have seen dynamic method dispatching, if you remember the previous sessions, where we create the instance of an interface and then create the object of implementing class. That's what I am doing here. Fine. So I have done that. Now what I am going to do is I will be creating the, instead of roll numbers, let's call it as names. And then let's add the elements accordingly. Names.add. So I'll just be adding some random names there. Usually this is the example I always take. Okay, Virat, maybe Rohit, and what? Pandya, Rahul. I'll add ABD so that I have somebody who's at the top so that I can understand that. Then let's add what? Let's add Dhoni. Okay, that's it. Let's finally add, or maybe Bumrah, so that I know that ABD and Bumrah should be 1 and 2. Okay, so now I want to sort the collection. So let's sort that names collection here. Names should be sorted, and here also I want to print the names after sorting it. So descending order sort, I want to perform names, the descending order sort for names, and I want to print names. So these collections that I am using, be it an integer or a string and all, so they already have the sorting logic, the comparable implemented with those classes, and it allows me to sort it. So you can see that this was the collection that I had before. I did not print it, so let's print it first, how the elements were added. After that we can perform sorting. So names, now it will show all three results to me. So this is how it looks like before. It maintained the order in which I have added the elements. After sorting, it is sorting it properly, looks good. Then in descending order sort, so it is sorting the descending order as well. So this way we can perform sorting even with the string object. Only problem will come up if we have our own object added into a list. So there we will get a problem when we try to sort it. Let's see how can we create a collection of user defined object. I think this video is already lengthy, so in the next session we will create a collection of a type player demo 5 string sorting. So in my next example, I will create a collection of type players, and then I will try to sort the player collection, because this player collection now contains multiple properties. So whether it will be sorted based on the name, based on the jersey number, or based on the rule. So that is something which we can decide, and in the next session itself we will learn what is comparable, what is comparator, difference between comparable and comparator. Okay, so tune in for that particular session. Collections is gonna be definitely interesting subject, interesting topic, but it is lengthy and more interview question. A lot of interview questions will be asked on collections itself. So at the end, as I always tell you, please share the videos so that it encourages me to create more such contents for you. Thank you. See you in the next video.